Okay guys, so this video is going to go over graphing and transformations of absolute value functions. If you're still not too sure how to do that or what the setup is for that, I would recommend that you watch the 2.2a, which gives the basics of what these look like. So there's a couple of things that you're going to need to do by the end of the video. You need to be able to identify the vertex and the axis of symmetry, approximate the zeros, state all of the transformations, graph, and you're going to need to be able to give me the domain and range. Okay, you'll be required to do all of these things on the exam without a calculator. So that's why it's really important for you to really understand what's happening in the functions. So just as a reminder, the formula for absolute value functions is a times the absolute value of x minus h plus k. Okay, so what I'm going to do for this example is we're just going to first list our values for a, h, and k, and then I'll give you the transformations. So our a is -1, which just means that our slope is -1. 1 does not change from the parent function. Remember, your parent function f of x is equal to the absolute value of x. That has the slope of 1. So the value of the slope doesn't change, but that negative value does. It does affect our transformations, and that gives us the reflection. Okay, which means that this is now going to open downwards instead of up. Okay, so these are going to be your transformations on the side. Okay, our h is 4. Remember, it's always opposite of the sign that's inside the absolute value. So h is our horizontal translation. It represents what happens on the x-axis. Okay, so this is a horizontal shift of +4. Okay, and then if you want to, you can say, it moves to the right 4. If you want to shorthand it, that's fine with me. K is +5, that doesn't change. K is our vertical translation, so we have a vertical shift of +5, which means it's going to shift up 5 units. Okay, so you can shorthand it up 5. A positive h is to the right, a negative h is going to be to the left. So that's it for our transformations. Now that we have a, h, and k, we can talk about our vertex. That's the point hk, or h is still opposite of whatever it is, so that's the point 4, 5. And our axis of symmetry is the line x equals h, so that's going to be the line x equals 4. It's really important that you don't tell me axis of symmetry is equal to 4. Okay, that's not good. You need to understand that the axis of symmetry is an actual line, so it has to be written, in that manner. So we identified the vertex axis of symmetry and we stated our transformations. So before we do our domain range and the zeros, we have to graph our function. So let's pretend these are straight lines. Okay, good enough. So first I'm going to graph our parent function, which is this one here, the absolute value of x. So that has a vertex at the origin and a slope of +1. So up 1 over 1, up 1, over 1, up 1, over 1, in both directions. Okay, I'm going to try to make these as accurate as possible. And so now I'm going to graph our function itself. So we know that the vertex is at 4, 5, so that's where you have to start. 1, 2, 3, 4, 1, 2, 3, 4, 5. Okay, and it has a slope of -1. So 1, 2, 3, 4, 1, 2, 3, 4, 5. Okay, so down 1, over 1, 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 down 1, over 1. Okay. And then in the other direction, down 1, over 1, down 1, over 1. Okay, and you want to go until you cross the x-axis. Okay, so right there. So then you can plot your graph. Okay, and then you can always use, sorry, that's not right. You can always use your calculator to double check your work. Okay, so there's our graph. Our vertex is at the point positive 4, 5. Our axis of symmetry goes straight through the middle at the line x equals 4. Okay, so we graphed it, and now we need to approximate the zeros. Now your zeros happen where your function crosses the x-axis. So that happens in two places here, right there at -1 and right there at 9. So when you state your zeros, do them over here. Okay, they're just the points, and I'm not asking you to solve for them. So it's at the point -1, 0 and 9, 0. Okay, we're not going to get into solving for zeros yet. You just need to approximate them. So it doesn't have to be perfect. If you know they're like in the middle, you can give me the 0.5s or whatever. The one thing that you do need to know is that you're not always going to have an exact value for those zeros. The last thing that you need to do is state the domain and range. Okay, now remember we covered this in the previous video, that the domain always for your absolute value functions is going to be all real numbers, because as you look at your function and it continues down, it's going to continue in the negative infinity direction on the left here, and as it continues down this way, it's also going to continue in the positive infinity direction here. So from negative infinity to infinity is going to give you all real numbers. Okay, so that should be a given for you. Now your range is a little bit different. If you start here at the x-axis and you work your way up, you're going to see that your graph comes to a stop at this point here. Okay, so that's going to be your upper bound or your maximum. Okay, at y equals 5. Okay, that's 5 right there. That's where it stops. So your upper bound, when you're looking at this, is 5. It's a closed circle. There's not a hole there at the vertex, so it's less than or equals to on this side. And then on the left, if you work your way down, well, you see that the arrows are continuing in the negative direction on both sides. So your lower bound is going to be negative infinity. Okay. Remember, you can write this in interval notation, close bracket 5, or you can just write y is less than or equal to 5. Okay, either of those will work. Okay, so there you have it. Your axis of symmetry and vertex, you graphed it, you approximated the zeros, we have our transformations and the domain and range. Be sure that you know how to do this for the exam. Alright guys, so in this example, I'm going to go through it fairly quickly. Okay, I'm going to list your A, H, and K. So our A is a positive 1/2, our H is 0. There's nothing inside that absolute value, so it's 0. And K is a positive 2. So A equals 1/2, which means our slope is 1/2, which means we are going to have a stretch of a factor of 1/2. Okay, remember, these are counterintuitive. If you see a fraction, it's actually going to make your graph wider. If you see a whole number, it's going to make your graph more narrow because of the steepness of the line. Our H is 0, so there's going to be no transformation here. And our K is 2, which means we have a vertical shift of positive 2. Okay, and if you're shorthanding, you can do up to. So here we can state our vertex, which is the point 0, 2, and our axis of symmetry is the line x equals 0. So from here we can go ahead and graph it. We start at the point 0, 2, up 1 over 2, up 1 over 2, up 1 over 2. Okay, and this is going to look wider here in my example than, if you were to graph it on a calculator. Up 1 over 2, up 1 over 2. Okay. Okay, and then our axis of symmetry goes right through the middle. It's the y-axis. It's the line x equals 0. Now to talk about our zeros. Remember, your zeros are where your function crosses the x-axis. So if you look here, it never crosses this line here. It never crosses it. So we're actually going to have no zeros here. Okay, so you can put none or NA. And the last thing we need to talk about is our domain and range. So remember that our domain is all real values. And that our range is a little bit different. So if we start here in the middle and we work our way down, we see that we actually have a minimum right here at this point. Okay, and that's the line y equals 2. So that's going to be our minimum value, our lower bound. So if we're setting up our inequality, this is going to be equal to, because it includes the vertex there. And if you work your way up, we see that our arrows continue in the upward direction, in the positive infinity direction here. Okay, so that is our range. Remember, it can be written in interval notation, close bracket at 2, because it includes that point to infinity. Or you could write y is greater than or equal to, 2. All right, I have one more video that talks about writing an equation from the graph, and also when you get to the more complex solutions or equations where you have values inside the absolute value. So be sure to go over that for the exam. If you have any questions, let me know. Shoot me an email, send me questions or your mind, or ask me in class when you see me.